Right now I'm going to introduce our next discussion panel. It's a future reach conversation, countering adversarial operations made possible by artificial intelligence. Moderating the panel is Dr. Matt Gaston. He's the director of the SEI Emerging Technology Center.
Thanks, Brenda. I'm back again, right in that after lunch slot. I'm trying to figure out on my own if that's maybe a punishment or I don't know. I'll let you be the judge. Welcome back, everyone. This panel is, I think, a really interesting panel, and we've assembled a great group that I know I'm excited to talk with. The title of the panel is Countering Adversarial Operations Made Possible by AI. I'd like to summarize it by just saying countering adversarial use of AI. And I'm actually going to challenge the panel to think about it from two different aspects. The first is adversaries using AI to do whatever it is that they do, but also the opportunities that are presented to adversaries based on our use, based on, say, DoD's use or the national security community's use of AI technologies. Again, I think our panel brings a very interesting and diverse set of backgrounds to this question, so I'm very much looking forward to the conversation. I'll introduce the panelists first, and then we'll dive in. As we did yesterday, I'm hoping we'll have some questions from the audience as well. So please put your thinking caps on and think of some really hard questions that you can ask our panelists. So first, to my left is Professor Liu Yu Bauer. Liu Yu is a professor both in the Electrical and Computer Engineering Department, as well as the Institute for Software Research, which is in the School of Computer Science here at CMU. His research spans many areas of computer security and privacy, and I'm sure he'll talk much more about this, but he's quite famous for some recent research on real-world attacks against machine learning systems, in particular 3D glasses that can be printed to defeat facial recognition systems, high-performing facial recognition systems. So I'm sure we'll dig in a bit more on that at some point. Welcome, Liu Yu. Thank you for being here. To Liu Yu's left is Professor Kathleen Carley. Kathleen's a professor in the Institute for Software Research here at CMU. And for a long time has been the director of a center called the Center for Computational Analysis of Social and Organizational Systems. But more recently, a new center was formed with a grant here at CMU. And that new center is the Center for Informed Democracy and Social Cybersecurity. Social cybersecurity. I like this term. I hope we learn a lot more about it. That center is really focused on disinformation through online channels. And the effects it has on an informed citizenry. So Kathleen brings that current perspective, and we'll have lots of ideas along those lines. And then last but not least, to Kathleen's left is Alan Householder. Alan is a senior vulnerability and an incident researcher in the CERT division here at the SEI at CMU. He's an expert in vulnerability management and vulnerability disclosure. And among other things, I know Alan will bring a very practical perspective to this question of adversarial use of AI. So that's our panelists. Thank you again for being here. It's my pleasure to join you up here. I thought we'd start with an easy question. So along the lines of adversarial use of AI, I'd like you each to sort of get us started by maybe in line just commenting on what are the things you're either most worried about today in the context of adversarial use of AI, or the thing you're most focused on. Liu Yu, let's go with you first.
Thanks very much. Let's see. So it probably won't come as a surprise that I'm going to talk a little bit about opportunities to adversaries based on our use of AI, because that overlaps the research that my group has been doing. So I imagine you're all familiar with the concept of an adversarial example to a classifier, right? Raise your hand if you're familiar. Okay, so familiar, right? So you've probably all seen the famous image of a panda being slightly perturbed so that it gets recognized as a gibbon by a state-of-the-art machine learning system that can identify objects and animals and images much better than humans can. So my group learned of this 4 or 5 years ago, this sort of weird behavior of some classifiers. And at that point, it seemed clear that behavior wasn't desirable, but it wasn't clear how much of a problem it was in practice, because is the panda really going to try to deceive some machine learning system by hacking into it and changing its image, right? So what my group tried to do is try to understand what are the real-world implications of this. And we went into two application domains. One is we tried to see, could these same sorts of vulnerabilities in machine learning classifiers be used to, for example, evade surveillance in some sort of practical relevant circumstance? And the other direction we looked at is, could the same vulnerabilities be used to mislead malware classifiers into accepting a piece of malware into thinking that a piece of malware is benign? And so, unfortunately, I guess fortunately in terms of publications, unfortunately in terms of the reality of the world, we succeeded in both of these dimensions in that we were able to show that an adversary could develop an algorithm which would let the adversary, for example, 3D print a pair of eyeglasses such that if the attacker wears them, they will be reliably recognized by a state-of-the-art machine learning algorithm as being somebody else or as not being themselves, whatever the adversary is trying to achieve. And similarly, we were able to show that if you take some of the state-of-the-art machine learning-based malware classifiers, you can come up with an algorithm which is going to take a piece of malware, which is identified as malware by the classifier, and transform it into another binary that has exactly the same functionality, but is no longer recognized as being malware. Right? And this isn't just hypothetical in the sense that this is also something that we went and tested against all the antivirus programs that are part of VirusTotal, and a lot of them also thought that this new piece of malware was no longer a malware. So one of my big concerns for us, for our use of machine learning, is that it will be so. So many of us are so excited about the opportunities that we get through using machine learning in our products and systems. And so I'm afraid that sometimes we will jump on the bandwagon too quickly and start using machine learning in mission-critical ways, not really recognizing that, oh, maybe this opens up the opportunity for the adversary to mislead us in some new ways. And this is not just in DoD applications, but in any application, in transportation, in power generation, whatever. There are many circumstances where an adversary might be able to take advantage.
Thank you, Leo. Kathleen, your concern of the day?
So obviously my concern is social cybersecurity, which we mean keeping the internet basically open for political and human debate without undue influence. So one of my big concerns is how the adversaries are actually employing AI in the form of bots, cyborgs, auto-generated memes that evolve, deepfakes, et cetera, and are using those to manipulate not just what messages you hear, but who you hear them from, are manipulating the prioritization rules of all the data providers to make sure that you get information in ways that you can't tell whether they're coming from your friend or from a personality, a celebrity type personality, or coming from these bots and cyborgs. These things, they're being used now to do things like solicit children into human trafficking. They're used to solicit individuals to engage in insider threat. They're used to hack elections. We've seen over 70 countries using this capability against their own populations. Increasingly, you can buy it. And increasingly, they're being used by marketing firms paid for by various covert groups.
Okay, thank you. And Alan?
So, from my perspective, as part of the vulnerability analysis group within CERT, and we kind of go back to the original founding of CERT for coordinating vulnerability disclosures and getting things fixed. I'm concerned about all of it. I don't have a specific area that's of concern, but just generally this idea that AI is still just software. Software still has vulnerabilities. It always has. It always will. There are some new twists that come about because of this. It used to be that software security was entirely about the control flow of the program and making sure that the program did what you expected it to do and all that. And now we have to actually consider the socio-technical system that the software resides in. We have so the way we think about security has been confidentiality, integrity, and availability, and some of that I think we need to expand into privacy and safety and fairness, because these things are starting to become more important, not just to the systems, but to the broader society at large. And the definition of there's lots of different definitions of vulnerabilities. NIST glossary, I think, has 17 different ones, all of which are just slightly different, and you can see sort of an evolution of how those things have changed over time. My concern is that anything that makes you exploitable by an adversary is a vulnerability, and it doesn't matter whether it's because of a bug in C code or if it's because of naive assumptions about the hostility of the environment or data bias. It doesn't matter. Like, those are all vulnerabilities. We got to deal with them all. We have to figure out ways of compensating for that when it happens, and build the systems not just to deploy the first version that meets the performance requirements, but the one also, when you find out that you're wrong, how do you deploy the next version, and how do you update and make sure that you're maintaining the ability to change the system, because the world changes around the system, even if the system is just sitting there minding its own business.
So the follow-up question that I wanted to ask, sort of for each of us, first, there's a lot we're going to cover here. We've already covered adversarial machine learning, social cybersecurity, and then sort of vulnerability management and disclosure, and how that's changing given all of these technologies. The next question I want to ask, and maybe going in reverse order this time, is what do we do about it? Like, now that this is a concern, or a renewed concern, and it's changing how we have to approach these problems, what can be done? How is CERT changing what it recommends to do in vulnerability disclosure? Given this, what do we do about patching these systems? Because it's not just about fixing the code anymore.
So in our case, I think there's making sure that the broader mechanisms are in place for receiving reports of problems, for the communication between whoever developed the system and the folks that can fix it, and then the folks that can deploy those fixes, and making sure that those communication channels are clear. Hopefully having automated update, and this is all applicable to general purpose software in addition to AI software. But the other thing is moving back up the stream to back up the process to the analysis phase, and when you're designing systems and things. For a long time we've been talking about threat modeling as a valuable tool and mechanism for people to understand, to think about the design phase of how to avoid vulnerabilities and how to avoid introducing those and how to test for them and where to know to look. And I think threat modeling can also extend into AI systems, and even go even broader. You got to consider who the stakeholders of. So there's the confidentiality of the data, but there's also the privacy of the data. Confidentiality from the standpoint of the system owner, but privacy from the standpoint of the data stakeholders. Equifax is the system owner. They care about confidentiality. I care about privacy. That was my data, or I'm affected by that data that leaks. Threat modeling for those sorts of things too, where you start to consider, who has something at stake that can be lost by the fact that your system has whatever properties it has, and what can you do about that? So I think that's for me just extending threat modeling, starting to think broader about vulnerability. More than just control of programs, into how does the system interact with the world around it, and what are the bad things that can happen, and how can you avoid those?
Okay. And Kathleen, in social cybersecurity, I think you motivated the problem nicely. What are some things that maybe we can do as individuals, or we can do collectively to mitigate these risks?
From a science perspective, we need to get better at doing early detection and warning systems to provide people with more information out there. Educationally, we need to help people understand what to look for in messages that indicates that they might be disinformation, such as typos in the URL, or gender mismatch in the people who are sending the messages and things like that. But aside from that, I think this is an area where we really need to think hard about new laws and policies that are needed, and what is going to actually be enforceable versus non-enforceable. Because a lot of the things that are being discussed right now as possible laws are blatantly not ever going to be enforceable, given the way AI is changing. And this is also an area where we have to start studying the trade-offs between privacy versus security, because there are things in which the way privacy is being defined by some companies is actually making it impossible to detect things like the spread of fake news. And so we need to look at those kind of trade-offs as well.
So if I can ask just a quick follow-up question, your answer there wasn't just a technical answer.
Correct.
Right? It wasn't just we have to solve this computer science problem or this technology problem. How is the community in this space pulling together different perspectives to go after this problem systematically?
So I'd say the community is forming, but it's very nascent at the moment. And there are people who view it as a purely technical problem, but that's wrong. But otherwise, there's a bunch of new groups that have been forming throughout this country and throughout Western Europe and in South America that are trying to bring together policymakers, academicians, corporate, all together in like common meetings to kind of start creating a sounding board. Like, here's what the issues are, because there's so many that people aren't sure of them. This is not just a technical issue.
I think this is becoming a common theme, at least in the conversations I've had over the last year, but certainly over the last 2 days, that to solve a lot of these problems around AI engineering, AI security, it's going to take a diversity of perspectives and expertise. Okay, Lujo, you know how to break facial recognition systems pretty reliably. You can fool them into thinking you're me or I'm you or something like that. Are we just in trouble?
Yes, right, and I think my opinion is kind of consistent with the tone I heard from Alan and Kathleen, which is that we don't have a detailed prescription for how to fix any of this, right? Our prescription is kind of, well, work on these large areas that will help, and so one of my prescriptions, I guess, is we need a lot more research to understand this better, right? This is super new technology that we're dealing with. It's very exciting technology, but because of what it can do, and that's what's leading to its very quick adoption. Right? But that just means that we need to be even more careful that the research on how to actually make it foolproof is proceeding as quickly as the research in how do you make this technology do one more pony trick for you. So I think that's one. I think another piece of advice is, if you are uncertain, don't use AI. Right? Yes, it's very sexy, but think about what the effects are. And this goes back to the threat modeling that Alan was thinking about. If my system now suddenly will have an AI component, I shouldn't be allowed to even use that system unless I have gone through the exercise of figuring out what's the worst case, how bad can it go if this AI component starts behaving in a totally unexpected way.
So just to link back to yesterday's panel, you'll be happy to know that Marshall too said more research funding in all of these areas. So there's consistency across everyone. So I think I want to come back to the threat modeling question in a bit. But you know, both Lujo and Kathleen, you're from the Institute for Software Research, where Bill Shirless was the department head for a long time. In conversations with Bill, a thing he liked to talk about was building security to systems. I'm wondering, for any of these problems, any of the things that we've discussed so far, are there approaches that will allow us, now that we're getting ready to build, use, deploy, integrate AI technologies, can we build security in? Is that even a concept? And if it is, what does it look like? And we can go anywhere from here. Anyone who's willing.
So,
No, go ahead.
I have a sort of a counterpoint to the build security in idea. And there's a talk I gave at B-Sides in Pittsburgh here a few years ago, where I introduced the Flatiron building in New York City as an example of a building that is susceptible to airplanes crashing into it, but it was built before the Wright brothers got off the ground. Systems outlive their threat models. And the faster the world's evolving, the faster your threat model goes sour, and you have to constantly reevaluate. Are the assumptions this thing was built under, do they still hold today? Do they still hold tomorrow? Do they and do they persist? And how do you recognize when they don't anymore? And the whole talk was going through the entire 20th century, and you have examples of planes crashing into buildings, you have examples of intentional terrorist attacks, you have all these things, and you wind up at September 11th, and you have a dramatic demonstration of this, and yet the defense still wasn't put anti-aircraft guns on top of every skyscraper. The defense is, you go completely outside of that level of abstraction and you fix it at a different level, and you add layers of defenses, and sometimes you scramble fighters, and sometimes you have policies, and you change the policies at airports, and you change a lot of other things. So, thinking outside of, it might not be draw a circle around this system and defend this system. It might be recognize that this system has weaknesses, and you counterbalance that with, defenses at other layers.
Other perspectives on this build security in idea?
So one of the areas that people have been talking about in the space, and I have no idea if this would work or not, is the idea of changing the whole internet such that no information can flow if it doesn't have its pedigree along with it, that it's completely becomes destructed if it doesn't have the pedigree. That's clearly a very expensive proposition. It may be completely impossible. That is one of the examples that people are talking about in this space. Another one is the idea that you may not be able to build security in, but you can expose assumptions behind the way the technology operates, such as the prioritization rules. The trouble with that is it has to be done in a way that, mere human beings can understand it. So that's the big problem in that area.
Yeah. I think I'll go back to the previous theme. I think one of the reasons we're having trouble coming up with answers is that I think we desperately need a better understanding as a community as to what to be doing about this. I think that for normal software, while maybe we never got to the point where we can assess its security as well as we would have liked to, at least we had lots of metrics and tools that we could apply and get some sense of, is this totally untrustworthy? Does it seem like it's reasonably robust, and so on? And for AI and machine learning in particular, I feel like we're nowhere near there. I think we still have to develop better metrics that we can apply to a large machine learning component to get any sense of whether this is junk or great. I think one thing that we can perhaps do in terms of building systems in the meanwhile is just try to limit a system's reliance on any one component. So while we always talked about layers of defense, maybe now that's even more important than ever. If you are using one machine learning component and you really want to be using a machine learning component in this spot, maybe you should use two very different ones and make sure that they agree before you act on what they say.
So a design pattern of redundancy or multiple algorithms running beside each other. Interesting. So you mentioned tools. I have to pick on tools. Many of the folks in the room, I'm just guessing, I could be completely wrong, aren't going to build their own machine learning systems. They're more likely to be acquiring them. Are there tools that they should be thinking about either investing in or starting to use? Is there anything available to start to address some of these kinds of issues when it comes to machine learning and the vulnerabilities associated with machine learning? And that's, again, for anyone, maybe just picking on Lujo because he mentioned tools.
Well, I have a quick answer, which is I don't have an answer. I'm not aware of any particularly useful tools that would do this kind of a thing.
Interesting. Alan, you might have a different perspective given that you're a vulnerability analyst. How do you find vulnerabilities in these kinds of things?
So we haven't done a whole lot trying to find vulnerabilities beyond and there's a lot of academic papers that talk about sort of the mathematical classes of problems and things that that are common across AI systems. We haven't gone to the point of of looking at many operational AI systems for tooling. Although I will say, gut feel, and I'm coming at this from the standpoint of black box fuzzing, which I've worked on for years. It turns out that software in general is really susceptible to just random mutation on, take good input, randomly mutate it, and throw it at and ask it, hey, does this make you feel crashy or not? And then the program crashes, and then you go and analyze it, and it turns out this is an exploitable thing. Ideas like that, assume that you're not creative. Humans may not be creative enough to come up with the test cases. You might have to have machine assistants to build the test cases and help you with that. So, there's a lot of ideas from fuzzing. Adversarial ML and fuzzing are really conceptually close to each other. They're very similar things. there's two different communities that come at that. There's the folks who did this from the software testing side of things, and they're talking about code and stuff, and then the adversarial ML's talking about math and calculus. So bridging that communications gap, I think, is going to be important in the next few years. But yeah, I genuinely believe if black box fuzzing works anywhere, it's going to work here too.
I think Lujo can show you.
Yeah.
Yeah.
Can show you back in his lab.
So can I?
Yes, please.
So from the social media analytics space, a lot of the tools out there for doing this are things like bot detectors, fake news detectors, and so on. And there's lots of them out there. And sure, you can go and pick up whichever one currently has the best accuracy scores. But they'll be wrong within 3 months because the things are just evolving so fast. So this is an area where you really need to be very agile and use multiple ones at once and triangulate on the answers. This is an area where you want to be able to plug and play new techniques in as they come on the market and as they become available, and so on. So it's very much one of these areas where you can't go off and just build the be-all and end-all system and hope that it'll work, because things are just moving too fast. You have to be able to use lots of things, and so interoperability is the key to all of the stuff that works right now.
We heard a lot about speed and agility with rigor this morning, so I think people are prepared for that. I'm going to go a little off script. I don't think it'll catch anyone by surprise up here, but I also want to give the warning that I'm going to open it to the floor in a moment for any questions. Kathleen, this will start with you, but I would welcome any comments here. What about deepfakes? I'll just leave it at that. What about deepfakes?
So the first thing on deepfakes is to realize that there's actually two different definitions that are available out there. One are the talking heads that I think are the more kind of cool ones, but the other one, and the way it's often used in DC, is simply to describe any deep influence campaign that is such that it takes excessive manpower and resources to discover. And so when we say deepfakes, it has these two meanings. Deepfakes are becoming slightly more common. The influence campaign type is very common. What's happening in this area is that it's actually it's getting easier and easier to buy companies who will build them for you and put them in place in a long enough time period in advance that by the time you notice them, everyone else goes, well, that's been around for a couple of years. Why should I care? As has been done in many election campaigns so far.
Any other responses to the what about deepfakes?
Well, maybe one addition is that one of the flavors of deepfakes is heads that look like a different person's head on somebody else's body. That's an example of AI being used as a tool to create attacks. And we haven't talked more about this, but I think that this is something that we should be thinking about in many other domains too. Right? So one example of a domain is maybe we should be really worrying about what can reinforcement learning do to find new attacks on systems that are sort of not novel systems, not using AI, but just systems that are difficult to attack, where you have to take a sequence of steps that if a human were trying to figure out what's the sequence, it might take them a really long time. But maybe reinforcement learning or some other type of AI can discover this much more efficiently, right? Or maybe situations like with spear phishing, right? So we know that when attackers actually carefully craft emails to individuals, right, that try to get them to type in their credentials or respond in some useful way, if they target specific individuals carefully, these emails are incredibly effective. Right? So now, how much of a risk is there of attackers building systems that use machine learning to craft these emails automatically, so that these effective attack tools become trivially cheap for them to manufacture and deploy?
Yeah, just amplifying that a little bit. I think we've all seen the phishing attempts that land in our inboxes that are spelled poorly. You know, if AI gets applied to improve the grammar of the phishing attacks, we're all in trouble, because that's a trivial capability that you would catch more people in that net just by improving the text if you're not a native language speaker.
So there's a I think well-known cost asymmetry in attacking and defending from a cybersecurity perspective. Does ML make that asymmetry even worse? Do we think?
Yep.
Probably in the early days it will.
Yeah.
I think it gets worse before it gets better.
Interesting. Okay, so we have some time for questions. I'm hoping there's a few out there. In case there's not, I have more. I'll point out to Lujo that there was a talk earlier today on inverse reinforcement learning. At the end of the talk, Eric Heim, a researcher here at the SEI, was asking for anyone that had a sequential activity problem. So maybe we'll get you hooked up and see where we can go with that. Okay, so I have one question that I'll try to read. There's a quote from an author, Victor Elias, I think it says. The basis for winning competitive warfare consists essentially in one condition: competitors with a relatively high risk of poor performance. So I guess that's saying that there's this one condition, and one of the competitors or all of the competitors have a high risk of poor performance. The question here is, do you agree? The basis for winning competitive warfare consists essentially in one condition. I guess one of the competitors with a relatively high risk of poor performance. This asymmetry we were just talking about sounds like what it's getting at. Do you agree with this quote?
So that sort of reminds me of some of Nassim Taleb's talk about the fragility.
Anti-fragility.
Well, not yet. So anti-fragility is when things gain from the volatility of their environment. But fragility is when volatility, or where you've got more downside, you've got more at risk than you have, than you might. Your potential for gain might be linear, but your potential for catastrophe could be elimination. And one of the main rules is if you want to play the game tomorrow, you got to survive today. So, I mean, I think there. One of the things when you're thinking about, and coming back to this idea of understanding what threats your system faces, is really, it's really important to understand how can you limit the downside of risk that you're taking on. You might get, substantial benefit from whatever applications you have using AI systems, but you also want to make sure that when it fails, it doesn't fail in a way that takes you out of the game. And maintain that ability to come back tomorrow and play again, because you can't win unless you can survive.
I think I really like that phrase, that if you want to play the game tomorrow, you have to survive today. And I feel like I feel like this is a phenomenon that's serving us very poorly now. And I think it might sometimes be functioning differently than you were suggesting, where I feel like in industry often, at least I've seen multiple examples of this. Companies sometimes feel that yes, they definitely need to invest more in security, but they also need to put out these new features for the next release because they're competing with somebody. And if they don't come up with this competitive new this new release with a competitive feature set, it doesn't really matter if they're totally insecure because they'll go out of business due to not selling their product. So. As I feel like sometimes this really works in both directions.
The debt payments sometimes come due in bulk, or in lump sums, and that's one of the risks. Is you can make a small incremental technical debt today, and you don't have to pay it, except stochastically later on you pay one big payment, and that might take you out of the game. So avoiding massive losses, even if they're rare, it's not. I'm not saying it's easy.
So from a social cybersecurity perspective, the statement is true, but it's trivially true, because you can always define something as being lower performance if they lost. But the real issue is not that. It's really even knowing that you're involved in a competitive engagement, and even knowing that there's someone who's trying to go counter to what you're doing, even recognizing that. And that's where I think the real issue is right now, in the use of AI in terms of manipulating people and groups and ideas in cyberspace.
Okay, now we're seeing some questions. There's one in the back.
Hi, my name's Darius Mikulski. I'm from the U.S. Army Ground Vehicle Systems Center. I was really happy to hear that the discussion kind of talked about countering some of these adversarial operations, not only from a technical perspective, but from a societal perspective. What I often notice is that from a legal standpoint and policies associated with those laws, those are severely lagging where the trends that technology and society are pushing. And so I wanted to just get your thoughts on the influence of laws and policies associated with those laws. And the context, I guess, behind this question is somewhat related to the new cybersecurity maturity model certification that's going to be required by DoD contractors in the next year, and what you think that type of policy is going to do to secure systems against attacks such as these.
With cyber policy or?
So I actually am not that familiar with the cybersecurity maturity model, so I don't have a comment on that. But real quickly, our involvement in the experience of the law recently has been, the SEI has been called to testify about vulnerability disclosure for the Meltdown Inspector situation that happened last year. And there's a lot of traction within the government on vulnerability disclosure being a good thing, and they want to promote that and build, establishing those channels, both from a response to the vulnerability, but also from a business standpoint. So the FTC has been doing enforcements on, I think, D-Link. They actually had a settlement with them where they tried to report vulnerabilities to D-Link, and D-Link didn't have a way to receive it. And so they, in their citation, like one of their problems that they cited was you didn't have any way to report this, and even when you did, you didn't have a way to get the patches out to the customers. That sort of thing only helps in the long run. At the same time, there's problems like all of the hacking laws that are really fuzzy on what exactly hacking is. And I've joked recently, there's self-driving Ubers that are circulating in this neighborhood of Pittsburgh, and you can buy T-shirts from Amazon.com that have stop signs all over them. And to Lujo's research, if I wear one of those T-shirts and I'm crossing Belfield, a block away, and one of those cars comes out and hits me, did I hack it? I don't know. There's going to be some really weird, situations that come up in the next few years, I think, because of the law. The law hasn't even caught up to the pre-AI world of technology, and it's nowhere near where it needs to be for the future. The law will be wrong in a lot of cases, and will have to be fixed. And hopefully, we're agile enough to adapt quickly and fix it.
So I definitely think we need to invest in more people getting both technical and law degrees so that we can get better laws. But in the meantime, I would say that there's actually a lot of movements to try to help educate lawmakers and policymakers about technology, which I think is again all to the good in this particular area. But the laws being out of date is not just a U.S. problem; it's a worldwide problem. At the recent NATO Strategic Partners Conference in Macedonia, they had several different countries come up and go through in detail their new proposed laws on, basically keeping the internet safe and open, so social cybersecurity laws. And they're very detailed, okay, but they're almost universally not enforceable, especially when you realize that you usually don't know where the attacks are coming from. You're legally bound to not collect the data that's under the dark web in a lot of cases. You don't have the right affordances, and then a lot of the attacks are global. They're not this is not just a national problem.
I would say that for DoD customers, I think there's often a lot of awareness of security issues, potential security issues on the customer's part, and so customers are able to put pressure on providers. But I think outside of that space, customers tend to be very clueless about security, and they don't know what to ask for, or what to demand. And I think for that domain, it's particularly helpful if there are standards or regulations that make it so that the supplier has to meet a certain bar, because otherwise they don't have a competitive reason to do it.
So I think I was glad to see a lot of hands go up. I think there's a lot of questions and conversations that could happen along this topic. We're running low on time, very low on time. So I want to close with a very, if you could each answer briefly, a two-part question. Yes, that's me, a two-part question. First, to channel Alan, some people in the audience might be feeling a bit crashy about machine learning at this point. I'm not. I'm still a machine learning optimist, even though I know a lot about how it can be attacked and what those vulnerabilities are. There's still a lot of opportunity there. So I'd like to hear from each of you, where are you on that optimism spectrum of machine learning in general, and also any one recommendation you might make to the audience?
I'll just say, I guess I'm a big optimist. It's just that I feel like sometimes we see people who have no pessimism at all, and I want to temper those people's optimism.
Okay, so I think that there's a lot of good things that are coming down the pike for machine learning. We just need to get better at knowing where and when to apply which type. But also, I think the big advances will be in human machine learning teaming, and I think there's a lot of potential there.
I'm actually optimistic. It may come as a surprise. Yeah, I think there's a ton of good that can come from this technology. But again, we just can't be naive about the downsides and the potential for downsides.
Great. Well, thank you, everyone. Please join me in thanking our panelists.